Perfect. Hello, everyone. So yeah, welcome again to that RapidPipeline plugin webinar for Unreal Engine. And this again, like the similar webinar I was holding in February this year, will also cover some of our updates on the CAD ingestion side. So basically, we have a twofold process here. One going on the CAD ingestion, CAD formats into Unreal. How does that work with RapidPipeline? What does RapidPipeline offer here? And then also in the other part, basically on optimization options. So once you have files into Unreal, which don't need necessarily to be CAD files, how can we further process them? How can we help optimizing them? What tools do we have which are not available in Unreal or Datasmith? And how can we basically complement your workflow? And at the end, I want to build in a quick session as well, if we have time for that. I'm asking you if you prefer a different integration method. So during that webinar, we will also talk a bit about the UI we have on the plugin side. And if you would, for example, prefer a more Python-based customizable approach as well. So that's something we're looking into. Yeah, to myself, like I'm head of 3D solutions and co-founder at DGG RapidPipeline. So I'm with the company from the beginning, about 8 to 9 years right now, and focusing basically on real-time 3D graphics initially, and then also on data acquisition, 3D data acquisition, scanning, and so on. And then over the years also handling more enterprise use cases and clients, and then together with the company basically around 2 to 3 years ago, starting also to support CAD data, parametric surfaces, and so on, and looking into how we get those ready for visualization with our tools. So basically, what is RapidPipeline? How did it start? So the tool started as an optimization suite, a little bit similar to maybe some folks of you are familiar with Simpligon and other tools like that, also like the classical LOD generation process, which is available in Unreal still, of course. And this is basically where our tool started. We started with things like mesh decimation, UV unwrapping, texture baking, and so on, all in an automated way. Then we have other features like remeshing, impostor generation, and like the typical kind of game or real-time ready optimization features. But as I said before, over the years, we also added then CAD capabilities. And now we're also diving a bit deeper into the visualization route of things. And we still have the offering of creating a derived downstream version of the model, even with compressions maybe in for WebGL and so on, like KTX texture compression, Draco mesh compression, for example, or mesh quantization compression on the vertices. So yeah, we have the whole downstream pipeline available as well. But we are also starting to cover other workflows, material assignment, and so on, and CAD ingestion, of course. So here you can see, yeah, just an example where we also have an optimization target, such as size on screen, which is very game engine related and relevant. On the plugin side, so we basically don't only have our core engine, and since a couple of months, we also have our own studio solution, Twin Studio, but that's also a topic for other webinars. So you can look up, I did a webinar not too long ago about Twin Studio. So if that's interesting for you, like a standalone application, feel free to check that out on our YouTube channel. But basically on the plugin side, we currently offer 5 ways, basically. We have coverage of 2 Autodesk products, 3ds Max and Maya. And then we have Blender, of course, which is basically our basically flagship DCC plugin, where basically the first one we developed actually, where we are furthest with the feature set. And then also we added the Unreal Engine plugin, which is the topic for today, and then also a Substance Painter plugin on that end. And how these plugins work at the moment. So in Unreal, it's actually integrate on a C++ level with a custom interface, which we will dive into today as well. And it will exchange data at the moment in GLTF format with the engine, because that's one of the formats we support best, next to also USD and other standardized formats. And especially on the material side, the exchange is pretty solid with Unreal Engine. But on the integration topic, yeah, as I said before, we have a little slot reserved to chat about that if you have feedback on that, or anything on the wish list in terms of getting a different way of exchange being basically natively integrated or via blueprints, for example. That's a different topic. Yeah, basically the core engine, we call it RPDE, is actually then running in the background and performing all the tasks on these exchanged files between Unreal Engine and the plugin. And yeah, as I said before, today basically we're going through 2 sections. One is the CAD import and cleanup section. And then if we have time, that's, I would say, more like the optional section. If you guys have also questions on that, the optimization 3D processing side of things. So if you want to further process, we have quite some features, but we know that Unreal Engine has some native features as well in terms of decimation, remeshing, and so on. But I think we have a few features on top of that as well. All right, let me quickly jump through the agenda for today, and then I will switch to the demo mode so I don't have to jump back to the presentation again. On the tessellation side, we basically have quite some presets already and also custom settings. I'll go over this in a bit. So from our preset side, from extra fine to extra coarse, basically, yeah, in general, we always recommend to go as high tessellated as possible to get the best detail. And then we can always decimate down from there. And our decimation algorithm actually is very good at picking up basically the curvature and being very adaptive in the tessellation at the end, compared to, for example, the extra coarse version here on the right, which is usually just suitable for a quick preview or maybe a more advanced collider mesh or something, but it's not really made for any visualization purposes. On the custom tessellation side, we have some more advanced settings, so you can steer how the topology should be generated, what's the max angle supported, and so on. So you basically can say, okay, on certain corners and maybe bevels, in a way, we want to have more topology distributed, and basically, for example, the surface deviation between the parametric surface and the tessellated surface should be on a certain accuracy. There are specific settings to set that as well, but I'll jump into that in the live demo session. We have a quite general, I would say, case agnostic winding order correction. So if I'm not mistaken, Unreal tries to correct normals and winding order as well on import for CAD files, but we have a option which actually operates with a raycaster, so it actually is independent of lots of particular issues with certain file formats or certain tessellation problems. So basically just activating that on import or with an additional preset to go over any mesh which has winding order problems usually fixes the issue and orients the actual faces in the correct way. In addition, we can also do, of course, normal recomputation. So for us, these are two separate things. First, we're looking at the winding order, and then we can also recompute any problems with the normals and have different settings for that as well. Then we have a feature which is called occlusion culling. This can be very helpful for basically culling out invisible parts. And the interesting thing here is that it completely is also batchable and works autonomously. So you don't have to create a volume or create a camera or like a distance plane or something to actually describe what is invisible and what not. And in this case, we also support materiality. If we have a material which is transparent, for example, it will still figure out that, for example, here in this case, the pizza slice is visible, and it will not remove it because the rays cast through a transparent surface. And again, this is also raycast based, so quite thorough on that end. We have a new feature, which I can demo today. And basically, it's a hole filling and defeaturing of circular holes. So it is currently flagged as an experimental feature still, but we were already working on basically the full release of this feature as well. But it is already in there, you can test it, and it basically works on circular holes at the moment. So that's one mode, basically. So it auto-detects circular holes and then fills them, and you have a max diameter setting for that, but I'll dive a bit deeper into that. And going forward, we're also looking at other shapes of holes and identification, and also an option to fill any types of holes or defeature any types of bore holes, through holes, complex geometry, for example, coming out of CAD. And then at the end, yeah, I have this section just going through, depending on how much time is left, on the typical optimization use cases. So for example, impostor generation, remeshing, texture baking, mesh simplification, decimation, and so on. And yeah, at the end, current features in progress. So as I said before, the hole filling, defeaturing, working on rectangular holes, working on kind of other shaped holes. So that's something in progress right now. And then we have also the quadrify meshes, which is not super relevant for Unreal Engine. Stuff gets triangulated anyways as it's a game engine. But what might be interesting is that we're also looking at optimizing the edge flow for basically like a quad-based tessellation. So this is something which might be interesting in general. But yeah, that's work in progress, not available yet. Exactly. All right. Yeah, let's go back to that simple tessellation topic, and let's just jump into the engine very quick. But yeah, if you have any questions at this point, feel free to ask. We pull up this very simple demo scene here at the moment. We just have a camera and basically ground plane. And let me just see in the outliner. So I pre-prepared basically all these steps, of course, for this webinar right now, so I don't have to load all these models in, but I will also demo very quickly how, for example, the CAD import works, and that's actually something we can start with right now. Once the RapidPipeline plugin is installed, it basically shows up here on the right side in your outliner, right next to your outliner basically, and the details panel, and you can see it's a custom interface. And right now I'm actually already demoing the version 1.3 of the plugin, which will be released end of this week, if I'm not mistaken. So this is a feature preview this time. And the big change for the interface on the plugin side is that we now have plugin categories. So before we had all our different processing actions into basically gathered together in one panel. And now we basically have categories as well, where the different processing actions are sorted more in a nicer way. So scene cleanup, that's a lot of stuff we're covering today on the CAD side as well, like after importing, tessellating a CAD data set, how can we clean up certain, run some clean operations, defeaturing holes and so on, what I talked about before. And then we have basically some of the optimization tasks separated out into decimation and baking, remeshing and baking. We have a UV section, which might not be super relevant today, so I'll actually skip that today. Yeah, you could somehow, of course, automate and create UVs in Unreal and then somehow apply textures to it. Usually that's done in other DCCs, right? But yeah, that's a general part of our plugin, which we also offer for other DCC tools such as Maya, Max, Blender, and so on. So there it's also super helpful. And yeah, you can do this in Unreal as well. And yeah, imposters also part of the optimization feature stack. Then we have the general import button here up here, and we can basically, let me see if I can just copy paste our folder here, and then basically select the CAD file in this case. We have a generator XT file, for example. In terms of supported CAD formats, see if I can pull up the documentation very quickly. We have that in our reference doc. And if you go to the 3D process documentation, format and material support, under CAD formats, that's basically the whole list of what CAD formats are supported right now and what features and on what software package. And basically, this gives you a good overview what CAD file formats are supported right now. So let's just import this XT file. And the first thing you will see, you get this import dialog here. And you have the choice between two options here. You have import 3D format and import CAD format. So technically, these are just exposing different settings. So you can import a CAD file with the import 3D format option, because then it will just use the default CAD import options. Or the other way around, you can import a non-CAD file with the CAD import options. We'll just ignore them and import with the default settings. But default settings, exactly. But basically, to fine-tune and steer your import process, of course, you can then go into, if you have a CAD file like I have right now, and dive a little bit deeper. So we have some of these presets, all of the presets I went through before. So from extra coarse to extra fine. But then you also have the custom option where you can then fine-tune the tessellation of the CAD file. And we also have a detailed documentation about what these values mean and how you can fine-tune this to your liking. So let me go just with the fine tessellation for now. We have the option to remove T-junctions, which is quite important. Sometimes in the tessellation process, we actually have very thin triangles, overlapping triangles. We have vertices, which are basically dead ends, not connected with a representative edge, basically to form a good triangulated surface. So this is something which cleans that up. We have a axis conversion, Y up to Z up in this case, Z up to Y up, as Unreal Engine, I think since 2025 is Y up. That's basically quite helpful if you get data from Rhino and so on when it's Z up, for example. And we already have a few of these cleanup options already here on the import process. So you can already fix the winding order, remove occluded parts if you want. But for now, this is a very simple file. I'll stick just with the T-junction removal, and we'll just import the file right now. So what it basically does is it just tessellates it now with the fine preset, so which should be rather high resolution, and with the defaults in terms of our edge length and other specific tessellation settings. See, should be done in a bit. And in terms of import and how it actually works, this is similar to how Datasmith would operate. So what you can see here is it actually popped up directly into the scene. So it's very similar to the Datasmith file import, that it basically appears here in the outliner as an also kind of as a game object that you can remove it, and you can actually access the different static meshes as well. But what also happens is that it will populate actually in the content browser. So if you go on the imported assets here, as you can see here, the generator showed up, and basically is here with all the imported materials and basically also the different static meshes and so on. So that's basically the standard way of getting the data set into the content browser and then also into the scene. Yeah, so in this case, this was the fine tessellation, so we could adjust that as well. One feature we don't have yet, but we're actually working on, is the retessellation. So if you have a problem with certain tessellation result with the parts, that you can basically retessellate it. For now, that's not available right now, but as I said, we're looking into that at the moment. But our general approach, usually, if you don't go too low with the tessellation resolution, as I mentioned before, extra cores or something, then you usually don't have issues with certain parts being under tessellated. It really depends also on what preset you use. Yeah, good question. Sorry that I somehow forgot to mention that. So right now I'm using Unreal Engine 5.61, I think, if I'm not mistaken, but we also support 5.7. So basically we started the plugin support with 5.6, and I think we still have the option, if it's really needed for like a larger project or something, to support a version before that. You can always talk with our team. But on the general support side, it's 5.6 and 5.7. And of course, we try to keep up with the new versions from Unreal. Yeah, as you can see, basically the materials are imported as well. And of course, we can do certain operations as well to make, for example, material assignments easier, right? Basically, if we look at the generator, and one thing which is maybe also interesting to know is that all our actions, they can be operated on parts of the model which you selected, but they can also be easily operated on the whole model, or in some circumstances, if the scene is not too complex, on multiple scene objects at once. So it's basically not limited to just doing everything part by part. The reason for that is also that these 3D processing operations are initially also designed for whole batch processing, right? So they're working very well with also like a larger model and processing basically the whole operation, the whole model. So one thing we could, for example, do is to simplify the scene structure a little bit. It's not the best example. It's just a very straight, flattened out node structure, but usually with more complex CAD files, we can have a very intricate hierarchy as well. But if we go back and we just go on the scene graph flattening, for example, what we could do is basically a flattening by material as well. We split multi-materials as well if we have multi-material assignments, and quickly run this. So this should basically help with also any further tasks. It would reduce draw calls as well by basically merging together nodes, but also for other tasks like assigning materials and just working a bit quicker with the model. This should help a lot. So if I'm going to the lit version here. So as you can see, before we had some separate parts here. And now what I did is a specific operation flattening by similar material, basically, which also can be done in an automated fashion, of course, if we're going for batch processing and so on. And basically what it did is it merged together objects which correspond to the same material, right? So this yellow material here, this gray material. And then this is also represented in the outliner. You can see that we have some of these nodes merged. So we're ending up with this amount of nodes instead of having, I think, almost like 5 times the amount of nodes, 4 times maybe. And what you can also see here with these hidden nodes is that actually we don't, if we do an operation, we don't replace the result. We don't replace the new result with the original model, but we are hiding the original model. So this usually this is the best approach in terms of don't lose any access to your original data. Of course, you can then, if you do like I did, like a whole operation on a model, you can also get rid of the original model if you don't need it anymore. But yeah, in terms of if you ever want to walk back or go back in terms of the original file and the original tessellation, for example, it's always there. It's not deleted. Yeah. And then, yeah, in terms of material assignment, that makes things also, of course, a lot easier. So if I'm going to the content browser here, some materials here, which I could assign, for example, like some metal. That was the wrong one here. Then this makes things a lot easier also with the assignment. See what this didn't work. There we go. So it assigns this to both sides and in parallel. So yeah, it just makes it a little bit easier in terms of working also with the But yeah, this is a very simple, not really representative case, of course, for workflow like that. So let me hide that again. And yeah, let me just unhide the actual demo version here for the cars. Let me go back into the wireframe mode. And here you can see the different imported versions of the car from the slides, where we go from extra coarse all the way to extra fine. And then on the left side, I even have versions with a custom tessellation where I went even more fine-grained in terms of the surface deviation, even less surface deviation allowance, basically, and then tessellating it even finer. And yeah, in this version, I did the same by material flattening, for example, which I just showed at the generator, with the generator on this car file. So basically then we don't have to one by one select the different parts of the car, but can, for example, just do a simple material assignment quite easily. Then there's one import option. Let me see if I can demo this a little bit here with the sewing. So when we do a CAD import, just do this again here, just bringing up the menu. We have an option for sewing distance and sewing tolerance, and that's always set to 0.05 millimeter at the moment. So all our CAD import settings, everything which operates on the CAD file is actually in millimeter, and the actual units in the processing we have are in meters, but we can translate between, of course, these units back and forth. Yeah, we're handling this in a way gracefully, so we're not mixing up any units here. And basically 0.05 millimeter means like it's a very small distance, but usually that's enough to actually merge the different patches which might appear on the CAD side and merge them into a whole solid, basically, so that we're doing that on the BREP, so before the actual tessellation, so that we end up with better fitting topology. And yeah, that's basically, it's not to be confused with what I just did on the flattening side. That's a little bit different, but this is actually already happening on the CAD side, on the tessellation side. Yeah, so that can be very helpful, specifically also with some of the automotive assets where you would have a lot of single small patches, and this is a nightmare to decimate or optimize or even process in terms of settings in anything further. Let me see in this example, we have a door file with no sewing, so you can see exactly what I mean by patches. So you have all these different resolutions, and they quite not really fit together very well. So basically, yeah, this is really, if you would take them all and then decimate, you get cracks, and like you have really problems. And a simple vertex by distance merging operation, something you could technically do as well, would not necessarily help here, because we're ending up with a lot of like T-junctions with a lot of vertices which have no correspondence on the other patch, for example, because of the resolution difference. So yeah, this is basically a nightmare for any further processing, even in visualization use cases. So basically what we always recommend, and that's why we have it as a default, to always operate on the patch sewing. So let's see. So I think I can actually blend them both in so they're next to each other. And here you can see on the sewing side, we actually have it resolved in a way. Let me see. Again. And basically having the whole object now merged into one, for example, this car door, and basically the tessellation fitting a lot better, and basically having it completely sewed together, and then having the tessellation operating on that suit level beforehand. So yeah, that's a lot, can be really helpful, and actually also helps to, with more complex models, not just this door example, to basically have parts merged together, which are basically logical. For example, in a robot arm, like a joint or something, instead of having just like an abundance of different patches. So this is, I would say, like a must-have feature. And yeah, we do that by default on import. So there shouldn't be any problems with the patches by default on import. Yeah, as you could see on the door side, there can be some problems with binding order actually. So what we did here is we did a Datasmith import. Let's see if I can pull this up. So I have them side by side here of this coffee machine model from Rhino. Actually, it's a 3DM file. And yeah, what can happen here is, and again, we're pretty certain that Unreal Engine also perhaps tries to do a winding order fix, so there's no exposed settings, so we might be wrong here. But usually software tries to fix those issues on import. But there are always files, as you might know, which have very specific problems, which just have duplicated surfaces or any type of interference where we will have problems with the winding order. And this coffee machine model here is one example for that. And this is sometimes in certain renderers, you can have basically double-sided shading active and then you're not even realizing it. But when you, for example, use that thing in a game engine like Unreal Engine, and then maybe you even port it to a mobile version where you only use a rasterizer as a renderer, no path tracing and so on, and no ray tracing, then this could very well be that, yeah, it will be quite visible and looks pretty broken. So that's actually something which is quite important to fix as well and to have an eye on. In other DCCs, there are always also visualization debug modes. For example, in Blender, there's a mode to actually visualize these winding order problems. So that's always something we recommend to keep in check, that there are actually no problems with that. And basically on the Rapid side, we have that part of our cleanup action where you can just fix the winding order. As of now in the plugin, it's just an exposed Boolean setting. You just fix the winding order or you don't. And we also plan in the future, of course, to add and expose some other settings if you want to have a fine-tuned approach. But for now, we basically set all the default settings on that regard, that it performs the ray casting. It can also deal with multiple meshes basically stacked in each other. So it checks where the sky is, checks where the origin of the scene is, and tries to orient all the faces accordingly, which in 99.9% of cases works perfectly fine. That's also one of the reasons we have it as a Boolean right now. So it's a very simple implementation. Optionally, you can also run this already on import if you want to be sure about it. That could, for example, help with like a batch processing or something where you want to import multiple files and always make sure that the winding order is correct. Yeah, so if you have any specific questions to how that works, you can always explain it a bit more on our core processing side. So basically outside of the Unreal plugin, we also have, as I said before, like quite detailed settings for that to fine tune how the winding order flip is actually working. And there are then different options. It could work per triangle. Right now, as a default, it always works per mesh lump, meaning not only per mesh, but any kind of connected pieces of triangles. So the smallest unit of a mesh, let's say, that would basically be checked against the sky and then flipped as a whole instead of just flipping per triangle. And yeah, I think we're a little bit behind in time. So if you have any questions, further questions regarding the winding order fix, happy to answer that. But yeah, out of time constraints, let me just jump forward and continue with the next section here. Yeah, so should be somewhere else in the scene. Oh yeah, zoom out a little bit. So here we have 3 different microwave models imported. And if I'm not mistaken, they're actually not from CAD, but doesn't really matter. We could also clean up invisible parts from CAD files, of course, and we can also do that on import. Yeah, the nanite question always comes up. That's a very good question. Very quickly, one thing about nanite is that at least on import, when we import, and I need to double check if that's for all files or for only for the CAD files, but what we did for at least for the static meshes, we deactivate nanite on that one by default. So from our testing, but to be fair, that's already a little bit outdated. The results with nanite were really not great, especially on topology coming from CAD, right? If you have certain parts where you have really high resolution details and then you have very low resolution faces and larger surfaces, that in almost all cases didn't work very well, and more traditional LODs either created with Unreal or with our decimation tools work way better than nanite in terms of the visual quality. But yeah, this is just as an FYI, we deactivate at the moment on the static meshes with importing. But yeah, we're happy to revisit that and see if we can have that interact in a way with nanite that it doesn't produce suboptimal results. So yeah, please let us know if you have any experience with nanite and any things on your wish list, let's say, just let us know. But at the moment, we ignore nanite basically. Yeah, coming back to the occlusion culling topic. So let me just double check on the lit mode. So what you can see here that, and let me just move the case a little bit here. So we have quite some interior geometry. Again, this is a very simple example model. Usually if you have a big CAD assembly, you have way more than just a fan, some cables, of course. But this is a good simple use case example case to demonstrate the capabilities we have on the occlusion culling side. If I'm not mistaken, there's a feature also which Unreal not natively has, and I think other more 3D optimization solutions have it in a different way, where you have to set a volume first, or like a camera distance and things. So for Rapid, there's none of this is needed. It's again raycast based, and again you have the option to, similar to the winding order correction, to do it per triangle or to do it per mesh lump, and you have a few more settings exposed actually in our occlusion culling action. So here it's called remove occluded parts, and you basically have a culling quality, which of course the faster the quality is, the less basically. So you get a result which is way faster, but you might not cull enough objects as you want to. Usually fast doesn't mean that it starts culling stuff which should be visible. It's just doing less raycasting, right? So it takes a bit less time, but therefore might be not catching all the invisible parts. And then you have also different options per mesh, which is not to be confused by the what we call the per part metric, which is actually per mesh lump. So per mesh is basically, should I, instead of looking at the microwave here as a whole thing, should I just look at each mesh part, like this part on its own, that part on its own? And that actually makes mostly only sense if you deactivate the per part, because then you actually check if the mesh self-intersects, and you want to remove what's sometimes called B-sides, or basically parts which are self-overlapping, and then you just remove the triangles which are then invisible through that self-overlap. That is usually then the use case for the per mesh metric. And then here in the middle, we have already the result where we basically just did the default settings with the visibility per part, and we were able to remove all the stuff. But let me just go back here and see if I can select that in the outliner here, get this whole microwave asset, and actually run the option here with the default settings, visibility per part. And yeah, with the default culling quality should also be rather quick. And again, this is also a very simple example. What we recommend actually when you have a really large CAD assembly and you already know that you don't need the interior geometry, you can activate that option on the CAD import as well. There's a little Boolean flag for that with default settings, basically. So yeah, we basically just did exactly reproduce the result we have here in the middle. One thing which you then maybe realize here is that this slice of pizza is still visible. And that's the cool thing I was mentioning before, that we know that this is a transparent object. And this is actually where this GLTF interchange between our plugin and Unreal actually helps a lot. Because if you have then a shader or like alpha blending or whatever you use for your transparency in an already existing actor in Unreal, we can then basically read that via the GLTF interchange, and we can realize, hey, this is transparent, and we're shooting the rays through, and we realize, hey, this pizza is actually visible, so don't remove that. But that's again optional, so we could also ignore the transparency, and that's exactly what we did here on this side, where we say, okay, even though there's a transparent material here, we're ignoring that, and we also want to remove this pizza because maybe we have a different shader on it, and at the end it might not be transparent at the end, etc. So yeah, we're quite flexible on the occlusion culling side here. We have another option which I think is not right now scheduled into the webinar, but I just want to mention it very quick, which is the removal of small parts. So if you have exactly knowledge about certain screws or very small intricate parts which you might not need, and they have a very specific size, you can also put that here in scene units, actually, in this case in meters, so 0.01 meters. What's the threshold of smaller parts you want to have deleted, right? That's an additional function you could use as well to just get rid of smaller parts. And yeah, of course, you could bake them also in. So there's a different topic, but I think that's more relevant if you want to do, for example, like a shrink wrap remeshing. That's more part of the optimization topic then. Oh yeah, and we created this result here, so we can just hide that away. So yeah, let's get to a very interesting and new topic, and this is something we touched briefly in the last seminar, in the last webinar actually, where we just foreshadowed it a bit as a future coming feature. And right now we have a first version, as I said before, it's right now in feature preview. And we have two options. We have fill surface holes and defeature solid holes. For now, I will mainly demo the defeaturing here because that's a more interesting algorithm, and it actually works on topological holes or like boreholes through holes which are basically supposed to be there and you will always get them. The fill surface holes is more like, okay, if there's actually a one-sided surface and it has a circular hole, that's not really that common. So usually that's broken topology. Maybe in very rare cases, it's actually on purpose, and then it would just fill up these circular holes on a one-sided plane, for example. But these solid holes are way more interesting, specifically in the context of CAD files, because yeah, you will always have them. And there are use cases where you want to remove them, especially smaller holes on a certain threshold. And yeah, so this is basically our new feature preview. Let me see if I can actually go and get the near plane a little bit adjusted so we can actually, so this robot is just 30 or 60 centimeters in size. So that's why it's that small. So it's actually the correct size, especially compared to the car models I showed before. So if we go in here, we have, for example, this plate, this plastic plate here in the robot model. And it has a lot of these small intricate holes here. Let's see if we can do the lip wireframe. Yeah, and this is maybe something, and that's maybe also the size of holes you want to remove. And let me just go ahead, go back to the lip mode, and let's just selectively run this on these types of holes. Right now, the default is 40 millimeters, so 4 centimeters in diameter. So that's basically the maximum threshold. So it wouldn't close any holes which are larger than that, but you can always, of course, adjust it. And yeah, you can run it like I'm doing it right now on the particular part, but you could also run it on the whole model and see what happens in terms of the size of holes which are closed. So as you can see, this closed the holes perfectly fine. And at the moment, something you need to keep in mind is that it only defeatures circular holes. So here on this robot, we also have other shaped holes like squares and so on. This is something actually we're working on at the moment. So it can also figure out what is a more rectangular hole and to close that. And the ultimate idea is that you will have an option to close any hole or filter for a certain shape of hole and do this then automatically. And of course, also in addition to have the max diameter or the max volume of that hole basically as a parameter. So when we go back into wireframe mode, we see that it's quite, I'm sorry for the auto-saving here. This is a quite simple closing in a way. I think the more advanced part is the detection also of these holes automatically. And you also don't have to, as you could see, you only have to select the model or the mesh or basically everything. So there's no hole you have to select manually. So this is all automated basically on these given parameters, the automation of the hole closing. But from the topology, you can see it's basically almost the same topology as before. It just fills up the holes in this case with like some triangles and a pole basically. But the cool thing is once the holes are actually removed, we can do something like a decimation, for example. And we could say, for example, this is basically a cube. So we go with 12 triangles, so six quads. And let's just run this in addition on top of the hole closing. And now if you would do this on the model with the holes, of course, we might get into problems in terms of the decimation because of the holes. And now that we have the holes closed, we have actually perfect perpendicular, like basically surfaces which are in a really good orientation also for the normals. And then now having this decimated is super easy, and even from the shape, sorry, a little bit Unreal WASD controls here. But yeah, basically having that file now completely cleaned up and just having a simple face works quite well. But yeah, so that would be always like a 7th step to have the decimation work. And yeah, for example, we can do the same here. And this, I think, will demonstrate quite well that it does not close the other holes at the moment, but that's basically on purpose. So as you can see here, we close all the surface, the circular holes on that surface, but ignore the other ones. And you might also be wondering why this hole, for example, wasn't closed. And that is another thing we're looking into. And again, this is feature preview. So that's how the tool works right now. As you can see, this hole actually penetrates a little bit into this bevel. And that makes it not perfectly circular shaped on a flat surface. And that's the limitation we have right now. So if you, for example, go to a different side of the model and we're selecting the side of the arm and run the operation again, only the holes which are really sitting directly on top of the flat surface, as you can see now, are closed. And the ones which are sitting on top of your curved surface or just barely on the edge of the bevel will not be closed at the moment. But that's something where we already have a fix, and we will update this with a patch, and then we will at that point also scratch the feature preview flag here. But that's, yeah, it's a minor improvement. And then you will also be able to defeature holes on different shaped surfaces, not only flat surfaces. So see that I can all those new parts I created. Yeah, and I see we're running a little bit out of time. We have 9 minutes left. So basically on the decimation side, I have a quick demo here with a chair. I think I just showed also how the decimation would work on that robot. Maybe we can skip that. So on the decimation side, I think the main thing you would basically presume, and the main thing we do is that for the default decimation, we can preserve the normals, we can preserve the existing UVs, so you won't lose any texture sets, right? You can just basically create an LOD with that feature. And yeah, it's very similar to the inbuilt traditional LOD creation Unreal has as well. But from our testing, basically our decimator is a bit more adaptive compared to other decimators and is able to go way more down in the resolution while keeping intricate details like little holes, for example, a lot better and not collapsing those compared to other decimators on the market right now. And yeah, a few additional flags, basically topology preservation. And what we have on the decimator as well as a deviation target, which is very interesting. So it's similar to the tessellation deviation, that it just looks at the original surface and then computes basically the maximum allowed downscaling on the edge collapses on the decimation compared to that value you dial in. Right now it's on percentage, so it's always relative. Doesn't matter what unit you have or what size the model is. It's always relative to what the deviation error, allowed error is. 0.005, for example, is a very small allowed error. And usually, basically, this can be paired with the face target as well. So you can say, I want maximum of 500K faces and a maximum error of, for example, 0.005%, 60% of the whole bounding box of the model. And then it gives you a resolution, but it will cut and cap that off at the 500K. Simple pillow would get maybe 30K resolution, while a whole diesel engine or something like that would then probably be a calculated version of whatever 700K, 900K, but would then be cut off the 500K you will set. So that's one of the features we have on top in terms of deviation. Yeah, let me quickly show the remeshing option we have. And in this demo here specifically, we are actually looking at alpha baking as well. So usually when we perform remeshing, and that's maybe one of the main difference to Unreal, is that we don't by default preserve the original, or we're not even trying to preserve the original texture coordinates and UVs, basically, because usually with a more aggressive remeshing, shrink wrapping, the UV coordinates will shift, and you will have actually issues with the accuracy in terms of the texture projection. What we usually do by default is always we recreate UVs. We basically do a whole pipeline within that remesher on the material side as well, and then don't have any inaccuracies in that regard on the reprojection of textures. So this example is a very interesting one where we're using all these features, the shrink wrapping, the baking, but we're also using alpha baking actually. So if we go here on the wireframe resolution, you can see a view mode here. You can see this is this little wire in that frame. This is all meshed, and basically this is something we, in this case, want to completely remesh. We want to get a completely low resolution representation. So if I, for example, switch to the detailed lighting mode and I'm blending in that, you see other wireframes here, and you see it's lighting only. Yeah, so lighting only mode. So with the default option we have under remesh bake, we're actually using the remesh and bake holes feature. So this is basically our alpha baking preset, which can not only just shrink wrap and bake materials, but it also identifies the gaps in the topology and then bakes those gaps into the alpha map as well. So in that case, what we did here is just a simple remesher. And if we go back to the lit wireframe one, or maybe the actual wireframe one is a bit better, you can see how massive the difference is in terms of the topology. So we got rid of completely all the little intricate mesh problems, or not problems, but details here, and basically have a very homogeneous remeshed version. And in terms of then, if we switch to the lit version, we have almost no difference here because we baked all of this just on these flat surfaces in terms of just on the texture side. So if let me see if I can find that right now on the processed asset category, or maybe on the material side. See, so this should be visible here that this is just an alpha material now, baked from the original mesh geometry, and that includes not only the color but also the roughness and the normal map, and in this case even the metallic. That's all automatically generated with that preset. And of course, we also have other presets here for baking decals, for example. So this can be useful if you have logos somewhere and you just want to bake them on top of a different surface. You can basically select both of them and then use that preset to generate that result. Yeah, and to round up the optimization part, let me see, we have also imposterization. So in this case, it's almost a little bit similar to the wireframe example I just showed before. Basically, what it does is that it works very good with foliage, of course. And let me see if I can pull up the imposterized version here. So when we compare it with the original foliage, and we go into the wireframe mode here, you can see that it's actually modeled, right? So it actually has a lot of triangles. And basically what we can do is we can bake also with the alpha baking approach on top of imposter. So in this case, this would generate quads, which are orientated in the shape and the position, and also takes into account the normals, the actual interpolated mesh normals of all these triangles, and positions the quads in a way that they match up with the original position, and then just performs the same alpha baking as we've seen with the remeshing result. And that basically leads to a result like this, where at the end we have, you see if I can go into the lighting only way, we have really just a kind of a cloud of quads generated, which are in the exact or approximated position of the original geometry. And then basically with the alpha baking and also including normal map and everything and PBR maps, we can basically simulate the look of the original leaves. And then for things like the stem here, for example, we would recommend rather using a decimation, for example. So it's also possible to do like imposters here, then it would just line up different quads and then project the alpha baking. That might look great from one perspective, but not from all of them. Yeah, for these parts, of course, we recommend then go more with the decimation approach, standard simplification. But yeah, and yeah, this is also a feature which can be automated on outside of Unreal on our core software. We also have batch processing optimized scene selection processes. So for example, you can say, hey, everything which already has an alpha map or so will be imposterized, and everything which doesn't will be just decimated. So there are certain rules which can be processed as well. All right, and I think, yeah, so this was the last point for the optimization side. I think we're running out of time, but if there are any last questions, I'm happy to answer them all. And other than that, thank you for your attention. And yeah, feel free to sign up on our website, rapidpipeline.com. Basically, we have a free trial, which not only includes the Unreal Engine plugin, but also all the other plugins with a test seat, which can be used for all the plugins. And you can also try our new app, Twin Studio, basically. So that's the offering where you get all the integrations, as I mentioned before, and you also get access to our new standalone Twin Studio software, which comes with the same feature set, the same actions which I showed today, and also a few more features with material assignment and open standard materials and a few other options and functionalities as well. Yeah, so if there are no further questions, I see there all questions are currently answered. Thank you for your attention, and yeah, see you in the next webinar, probably by my colleague Eric Chadwick. All right. Thank you, everyone. Have a great day. Thanks, Christian.